Welcome. My name is Ron Papa Schmidt, and I'm the creator of the Net Zero Now YouTube channel. This is going to be video 5 of the relaunch of that channel. And today we're going to talk about how do we know projecting our climate future. When I relaunched the channel, one of the most important videos I'll ever do is video 2, where we talked about what's our current path, the Titanic table. And in prior videos, in video 2, I talked about the table, its calculations, how it, the process by which it was created, etc., where the information came from, and those kinds of things. In video 3, I talked about where they got the information to do this, and actually the information to calculate actual temperature and the projections. Video 4, I talked about how we do actual calculations. And in this video, I'm going to talk about how do we do climate projections. So if you take a look at the Titanic table below, that is the black area that you see. So we're going to talk about when they project we're going to get to 2 degrees, 3 degrees, and 4 degrees Celsius. And then the other thing we're going to talk about is what the climate scientists say is going to happen to us in terms of living conditions on Earth when we reach that level. And then the other thing is what level of agreement is there among the scientists that that's what's going to happen. So that's what we're going to talk about in this video. And then to let you know, there's another video I'm going to do that is going to talk about why climate models underestimate our reality. I was originally going to include that in this video, but it just got way too long. So I decided to create a separate video to talk about that. So let's begin. So how do we project our climate future? If you sort of look at that question, you see you probably ask some fundamental sort of questions, right? Okay, is there sort of an authority or a single authority or a group of authorities that are universally acceptable? Everybody agrees that these are the real authorities around the world. An authority they can say, yeah, these climate projections are probably as accurate as we can get. And then the second question you'd ask is, okay, how do those organizations, who are they? How do they get funded? How do they work? What's their process like? Those kinds of questions. And then the next question would probably be, okay, well, so if they got these, where do the scientists get the information to do these kinds of calculations? And the fourth thing is then, okay, so if this group of scientists or whoever it is generates these projections, what kind of review process is there? How do we know what they're producing is accurate? How does that get? What's the process to sort of criticize it, critique it, etc., and things like that? Well, those 4 questions we're going to talk about in this video today. That's the purpose of this video. There's the fifth question out there, as I talked about before, and why do these highly sophisticated climate models consistently underestimate the real pace of temperature acceleration? And we'll talk about that as a separate subject in video 7. So let's dive into this video now. So yes, there is a single organization in the world that is recognized across the globe as the authority in terms of doing climate projections. The name of that organization is the IPCC, or the Intergovernmental Panel on Climate Change. It was really created in 1988 by the World Meteorological Organization. We talked about them in video 3. And in the United Nations Environmental Program. And they're the ones that decided there was a need for this, and they established it in 1988. So one of the things that exists here is sort of a clear sort of division of labor. Okay, so the WMO, their role in the world is to collect data about what's happening into our climate and process that data and make it available to everybody. The WCRP, or the World Climate Research Program, it was really created to sort of say, well, what are some international modeling standards? So we're going to do these climate models. What are some standards we ought to use? What would be some experimental criteria we ought to be using? And they sort of create what they call the CMAPS framework. And then we have the IPCC. And the reason it was created to really be an objective, non-political, synthesis entity to assess systemic climate risk. So as opposed to individual nations or people doing this, they thought it made sense to pool their money and pull everybody together to sort of come up with a way of really sort of telling us what's happening. And but synthesis here is a very important word. This is not a research organization. What they do is they go out and review all the research that's generated around the globe, and they sort of synthesize it or put it together. That's their role. It's a relatively small organization, okay? It's co-located with the WMO in Geneva, Switzerland. It only has 15 people in it, so it's not a large organization. And they're mostly administrative and coordinating kinds of people, okay? All the, the administrative activities like payroll and legal and all those things are just outsourced to the WMO and their staff. And it only has a budget of $9 million a year. So the good thing about that is it's not subject to financial influence by the United States or fossil fuel producing countries. So $9 million is pocket change, okay, in the scope of the world here, okay? And so I think that's really a very positive thing. So what's their structure look like? They're created, when they were created, they have sort of this sovereign framework, they call it. They have 195 nations, they call them sovereign nations, that are a part of this group. They in turn form the plenary. And so that means each nation gets one representative. They have equal votes on the plenary, and all major decisions require unanimous consent among all 195 member states. So when you see something kind of this organization, you got to say, okay, this was approved by the fossil fuel producing countries. This is approved by the major powers like the United States, China, and Russia. It has been approved by everybody, individual countries within the EU, but it's also done of poor countries. Even some remote islands in the Pacific have as much weight and authority as some of the bigger countries do here, which I think is really important. So you have this natural tension that sort of leads you to sort of a balanced answer. Now how they do this is then this group selects 34, they're called unpaid IPC bureau leaders. These are experts. There are a number of people that are nominated, and they select 34 of them, and they represent countries on all 6 continents of the world. And they're sort of elected to sort of manage the assessment cycles that go on here. They receive no salary from the IPCC. Their salaries and other things are all paid for by their individual countries. So they work on a decentralized model. As we talked about earlier in the previous slide, they have zero research budget. So they're not doing research. Their job is to coordinate and say, objectively look at what's being done around the world and saying, here's what we think is happening. And they call it 100% in-kind workforce. There's thousands of people that get involved in this process, okay, but all of them are paid for by their individual countries. Occasionally, the IPCC will pay for some travel-related expenses. Now, the key structural issue of this is they're sort of divided into 3 working groups. The first working group, or working group 1, is called the physical science basis. What they do is they evaluate the sort of the fundamental physics that are driving Earth's climate system. And then they go about attributing changes that are occurring. Are they caused by human being, or are they caused by just natural causes? And they also deal with modeling of future planetary entry pathways. So what happens if this happens, or what happens if we have this level of greenhouse gases, etc., things like that. Who makes up this group? are experts from around the globe, all 6 continents, that are experts in either atmospheric physics, meteorology, oceanographers, glaciologists, supercomputer modeling, climate modeling experts. That's the kinds of expertise that's in this particular working group. Okay. The second working group deals with impacts, adaptation, and vulnerabilities. Okay, so they're evaluating social, economic, and natural ecosystem vulnerabilities, risks, adaptation limits, etc., and things like that. And so who's on this group? There are a lot of ecologists, hydrologists, public health experts, agricultural experts, resource economists, etc. And then the third working group is sort of the group that focuses on mitigation of climate change. And they sort of vet, actionable kinds of pathways to reduce emissions or accelerate carbon removal from the atmosphere. And their kind of expertise deals with energy engineers, industrial analysts, urban planners, technology specialists, macroeconomists, etc. So these working groups really are what drive what's going on here. These working groups are formed by worldwide recognized experts, and they're selected from all of the continents of the Earth. So it's a very diversified, highly qualified group of people that are doing this work. Now, let me talk briefly about the cycle. I'm just going to go to real high level. So as we talk about individual pieces here, you can sort of see how it all fits into a context, okay? So the last assessment cycle they did was really a 7-year cycle. And here's how it comes. The first year they came together, they put together the plan, what kind of pathways we're going to run, what sort of, what stages are we going to go, what are the state planning stages we're going to do, what steps are we going to take, how are we going to do that, all those kinds of organizational things. The second thing then that happens is that those groups then sort of form what they call the CMAP standards. And what those really represent is they sort of lock down the sort of physical scenarios they're going to talk about. So identify what are some possible scenarios of what's going to happen in the future in terms of human behavior. And we'll talk about that in more detail here in just a second. And so they lock down those. And then the other thing they do is say, okay, so what are also other kinds of possibilities in terms of the level of greenhouse gases that are going to be in the atmosphere? And they lock down those protocols. Okay, then what happens after that's all done is they feed them to a group of supercomputers. Now, these computer models have all been pre-approved and gone through rigorous testing, and we'll talk about that in a second too. But it turns out there are 50 modeling centers across 6 continents. Now, several of these monitoring centers run multiple models, so in total there are about 100 approved models that really run calculations in this simulation here. And when that output is done, that whether they do, they analyze it, and then they generate a report. So that's sort of the process that goes on. It takes 7 years to do that, and we'll walk you through that on a year-by-year basis here. Okay, so let's talk about what's the history of the IPC. When they first started out, they're formed in 1988. By 1990, they did their first assessment. It was relatively primitive climate simulation that sort of talked about what was happening, and it proved that human-driven greenhouse gases were really warming the atmosphere. And as a result of that, the UN decided to create the UN Framework Convention on Climate Change. Then they ran another assessment in 1995, And what they did is they did more advanced mathematics were available then, and they basically were able to discern that human behavior was influencing temperatures, and that led to the Kyoto protocols. The third assessment occurred in 2001, and you notice these are getting a little bit longer between assessments, and that's because they're becoming more sophisticated. And so here they introduced sort of high resolution grids, and they really sort of created what they call the hockey stick, which showed that temperatures were sort of going straight, but now they're escalating at an ever increasing pace. And so that led to sort of increased political awareness around the globe that, gee, I think we got potentially a problem here. The fourth assessment was done in 2007. That's when the report was issued. And it just went on and said unequivocally, we now have proof that the climate is warming and that human beings are influencing that increase in temperature. Our behavior is. And that led to the Nobel Peace Prize for the IPCC and for Al Gore. Report 5 was issued in 2014, so it was like 7 years later now. And this was, again, each year these things get more sophisticated, okay? So it takes longer to do them. And they sort of were able to identify and just prove the thresholds that climate change was just, carbon cycle was just sort of pervasive and potentially irreversible impacts if something wasn't done. That led to the Paris agreements when 196 nations signed that agreement with the objective, and what they said they would do is limit greenhouse gases increases to 1.5 degrees Celsius by 2050 and make sure that we stayed under 2 degrees Celsius by the year 2100. Then you had the sixth assessment, which was just released in 2023. And this, the information produced on that created over 30 terabytes of just open source simulations and information coming from 50 global centers, just a massively enhanced kind of effort. And I think as a result of this, it's become an unassailable fact, okay, that climate change is real and that human behavior is influencing the temperature increases that we have. So that's sort of the history of the IPCC and their different report cycles. So let's go into now and explore in detail how the last one was done, AR. They call it AR6 or Assessment 6. And this was a 7-year cycle, as I had mentioned previously. So I'm going to go through this now year by year. So the first year, what they do, they sort of is involved in sort of scoping and sort of the foundation of the whole effort, or putting the blueprint together to what they're going to do. They negotiate what scenarios they're going to run. And the scenarios, they break them into two categories. One are what they call shared social economic pathways. This is sort of, okay, what are the potential paths that are going to happen as a result of human behavior? And then the next thing is they also identify sort of 5 physical greenhouse gas levels. Maybe one way to think about it is, okay, what kind of greenhouse gas levels will there be in the atmosphere? You could think of it like blankets, maybe. So on the lowest level, you have sort of like a thin sheet. At the middle level, you may have a comforter, and at the highest level, you may have a very warm duvet, okay? And so those are the scenarios that they create, and they all do this, so they agree on those things in year 1. Now, I thought I would just show you, in case you see some information, what this looks like, because you may have seen it in some printing materials and other kinds of things like that, but they have a naming convention they follow. So when you see this, the example here, it's got SSP 3-7.0. So SSP3 means this is the third scenario that they were going to run for the shared social economic pathway. And that sort of said there was a fractured world of surging nationalism and heavy fossil fuel kind of usage. And then they had, for that scenario, they decided to run level 7. And we'll talk about that in a second. That's the level of greenhouse gases that result. And what that number represents is really watts per square meter of radiative forcing energy, which nobody's going to be able to understand and relate to. So think about it like thickness of a blanket, okay? Now, we talked about the 5 scenarios that they were going to run, or the SSPs. So I wanted to list those here so you could see what they were. So the first one, SSP1, talks about sustainability. And that says the globe will take this really seriously and will get the net zero greenhouse gas emissions by 2050. Now, in this case, they decided to run 2 different energy levels or blanket thickness levels for this scenario. And we'll talk about those in just a second. SSP2 is sort of the middle of the road thing. So we've sort of followed the historical pattern. We gradually take it seriously, and eventually we sort of probably meet what the Paris Climate Accord said, and we'd be above 1.5 degrees. We wouldn't get the zero greenhouse gas emissions by 2050, but we would stay below 2% at 2100. And basically, they ran one scenario at that 4.5% thickness level. The third scenario then was sort of what they call regional rivalries, where you'd have surging national conflicts, nations relying heavily on inefficient local carbon-heavy fuels. That would be, and that they ran at a blanket level of 7. SSP4 was inequality. And so the high-income nations would adapt green tech, but developing countries would remain locked in sort of cheap fossil fuels. And they ran a couple of scenarios on that. And then the last one is full fossil fuel development. And there would be heavy use and increase in use of greenhouse gas generating kinds of fuels like coal, oil, and gas. And that would produce a very high level, the highest level of greenhouse gas levels. And then basically that usage would probably double or triple by 2075. That would be sort of if the climate deniers would be in control, 100% in control, that's probably what the result would be. Now, one other thing I want to mention, these models are incredibly expensive to run, take tons of time, et cetera, and things like that. So a number of countries, in fact, most of them, the models did not run scenario 4. So they only ran 5 real scenarios as opposed to 7. So most of this, from now on, I'm just going to really talk about the 5 scenarios that they did run, but there were some countries that did and some models that did run scenario 4. Okay, now let's get into the level of trapped energy as they talk about it. And I like to talk about that in terms of blankets because I think it's easier to relate to, okay? So 1.9, look at it as a thin sheet. That says by the year 2100, we were able to continue to stay below 1.5 degrees Celsius. That's probably not realistic today because we've already hit 1.5 degrees Celsius in 2024 if you looked at some of our other scenarios. But anyway, that's the optimistic view, okay? The second one, 2.6, this says there's aggressive global carbon reduction, but that prevents massive heat buildup. And we sort of followed sort of what we agreed to in the Paris Accords and so on. By the year 2100, we only got to 1.8 degrees Celsius and probably never get any higher than that. 4.5 says peak emissions around 2050, and then there would be a slow, steady decline. In that case, we would get to sort of a disruptive 2.7 degrees Celsius by 2100. version 7 is there's geothermal division. This would be a thick winter comforter. And here we get to a relatively chaotic 3.6 degrees Celsius by 2100. And then 8.5 full fossil fuel, tripling by 2075. This would be the climate deniers in control. We'd probably end up with the worst case of probably around 4.4 degrees Celsius by 2100. So those are the scenarios that we run. Now, before we do that, I just want to spend a second to talk about what happens in terms of the models. Okay, so these models are just not random. They have to be pre-approved before they're allowed to participate in this process. And that entire pre-approval process is subject to 100% peer review by anybody that wants to participate. You got to show your source code, you got to show your data, show your results, etc., and things like that. And one of the things you've got to be able to do with your model is you've got to be able to go back to 1850 and be able to, and up to 2014, and be able to model sort of past behaviors. So, okay, so your model was accurate in the past, so that becomes important. In addition to that, though, you can't just at an aggregate level, you got to be able to deal with some unique events that just happened, like a volcano. So in this case, they included the 1991 Mount Pinatubo volcano. Your model had to be able to actively react to that particular event also. Anyway, so as you're going through this elaborate testing process and everybody's examining everybody else's model, once you get through, you're able to prove that you are historically accurate and that your model should work for the future, you're almost approved. And then they do a sort of a hot test, make sure that, okay, now how does it look like what's happening in the future is sort of a reasonable results. They're not all running in one direction or another. But anyway, as they go through and they finally get through all these things, your model gets approved. If your model is not approved, you do not participate in this exercise. And so when they got through this approval process, they basically ended up with 50 modeling centers around the globe that participated in this, running about 100 models. Once the model is approved, it is absolutely just locked down. No changes, nothing, you can't touch it. And then what happens is that all these models at the same time get fed these scenarios, and then they go through this massive calculation to sort of project what's going to happen in the future. So that's the process, okay? So now in year 2, that's what's done by year 1 or before, okay? So year 2, they've now handed the scripts to the supercomputers in these 50 modeling centers into 6 continents, and they're producing their results. In year phase 3, they're sort of finalizing their sort of modeling things and starting to issue their reports and things like that. At the same time, these working groups have been formed and are looking at all the current research across the globe. Again, these are not original research organizations. What they do is they look at, okay, so what is all the research across the globe that we can look at telling us is going to happen at these potential different temperature levels? And how does that all work? And there may be experts in what happens with Greenland, with ice sheets and others with volcanoes. And so they're all looking at it from different perspectives, and they're trying to come up with what they think is going to happen. What happens then is, by year 4, they're sort of creating their first draft of what's going to happen with regard to of these reports. And then what happens is they go through sort of then a peer review of that draft. So that means that everything they produce gets reviewed, open up to the scientific community and others for an independent review and critique. And they then in turn critique what they're saying in these models. And they get tens of thousands of responses or critiques. Every single critique needs to be read, It needs to be responded to by these working teams in writing. And all of that correspondence is available to anybody to look at. And as they get through this process then, they start creating their sort of what I would call a heavily refined second draft. Now, what are they focusing on? Now, the climate model people are just focusing on the numbers, but the working group 2 and 3 sort of work on this is the element of the Titanic table that they're working on. And that is the physical impact of global warming levels. So these experts around the world are looking at all the research and they're saying, okay, this is what we believe the scientists of the world are saying. At 1.5 degrees Celsius, you will see significant environmental, economic, and social impacts. And the agreement level is very high. The agreement level does not mean that level is very high among the client scientists that are doing that. It means as they review the research around the globe, the latest research, there's a very high level of confidence that that was going to happen. You're never going to have 100%, so very high, maybe in the high 90s or something like that. But that's sort of, you could call that almost, that's what the world is saying they think is going to happen at 1.5. The same thing at 2 degrees Celsius. So when they say the world sees catastrophic and likely irreversible damage, what that really means is the elite set of specialists that we have assigned to Working Group 2 have looked at all of the current research, and they have said, this is what this research is telling us, and that there's very high level of agreement from the research that we looked at that this is what's happening, and also in our group. Okay, at 3 degrees Celsius, that same process tells us it's a nightmare scenario. 2 means that maybe human beings are not going to be able to do anything to correct it. By 3, we're just living in what they call a nightmare scenario. And they say that's what we can tell from all the research that we've looked at. And these are the world's experts doing that, right? And that as we look at the research, there's a pretty high level that that's what's going to happen. And then fourth, at 4 degrees Celsius, they say the planet will basically be unrecognizable to human beings. And as we look at the research, it's sort of medium to high level of confidence in that level. So that's what's going on in this reporting process, okay? So one group's doing the numbers, another group's looking at the literature and saying, here's what happens when we reach those different kinds of levels. Okay, so what happens in year 6? Year 6 is when we have the governmental review phase. And so now, as these groups finish their second draft, and they don't issue the whole report at once, as they get sections done, they're open to, again, another level of review. And now they're open to simultaneous review by all 195 members of the planetary. And then they continue to go through that process as it goes through the cycles. And these groups have different timings with them. But as you get to year 7, this is when you have the line-by-line review of what is going on. So every single line in what they call the summary of the policymakers, every single line in that assembly has been agreed to with 100% consensus. That means, when that number is there, that means the fossil fuel producing countries and the people of the remote island in the Pacific and every other country around the world agrees this is what's going to happen. So when you see this information in the Titanic table, understand that that means there is 100% consensus among the experts of the world that this is going to happen. And that means China, United States, Russia, Bangladesh, etc. Okay, and then they finally issue their final report. Now, one other thing I just want to say, so the politicians get together and they sort of agree on these things. Well, how do you make sure we got scientific integrity here? So that's, I just want to cover this briefly, okay? So the government officials can only comment on the summary report. They're not allowed to change or comment on sort of the working documents, okay? The second thing that happens is, so when they come up with the summary report and they make changes to it, they say, well, we've talked about it, here's our proposed consensus of what we think we want to say. That's through going through the compromise of the fossil fuel producing countries and those that are being impacted by it, etc. So here's what we agree. Now, the scientists, though, are given veto power. They can say, yeah, you all agreed to that, but that's not what the science says, okay? The science says this, go back, reword this, come up with a better agreement, okay? Words that reflect what the science is saying. So that's how they maintain integrity in the final report that goes out. And so when they're done, you know that the scientists have agreed along with all these different countries. And given the conflicts of checks and balances and other kinds of things, I can't think of a better way of doing this. If you were to design something and said, okay, objectively, I'd like to see what's really happening with regard to climate in the future, I don't think you could design a better process than this. Because it's got all the appropriate checks and balances, and everything is open to the public. And so when a member of the planetary makes a comment, his comment is exactly put into this report, and you can see the responses and things like that. So everything is open. It's an open public portal, and that also adds to the integrity of the process. So here's exactly what happened. Here are the final projections that they came up with. And so let me talk about the 5 scenarios that everybody ran. SSP1-1.9, which is the low emissions getting to net zero by 2050. It showed that we'd reach 1.5 degrees Celsius in 2035, and then we'd never get any higher than that. And we did the same thing for the other scenarios here. Now, one other thing I want to mention is that when they talk about these numbers, they do it with a 20-year moving average. The reason they do that is that there's a lot of, if you look at any of the charts we talked about in previous presentations, you can see there's a lot of ups and downs occur as a result of what happens with the La Nina and El Nino cycles. Okay, they have a heavy influence on year-to-year temperatures. But with a 20-year average, you sort of smooth all that out. So when they present numbers, it's always a 20-year average number. And how they do that is they then say, they take the middle of that, and that's what's represented here. So when you see 2030, for example, 2030 would mean that we've reached that level between the 20-year moving average from 1920 to 1939. Basically, that 20-year period has now reached the threshold where that average is now, let's say, gone to 1.5 degrees Celsius. Therefore, because that means sometimes it's going to be below that, other times above it, what they do is they take the median of that, or the 10-year point, and that's what they report here. And so let me go through here the columns. So at 1.5 degrees Celsius, we had a range of 2035 that was done by the models, the scenario under which we would not get to 1.5 degrees Celsius. We'd be a low emission by 2050. We can, and then if you go to the one below that, what it says is that we would get there in the period between 2020 and 2040, and therefore they had 2030. The next column over 2%, it says, well, the 1.9 never reaches that level because it's sort of stopped at 1.5. And that we get to the low emissions level would basically get us to in 2050, and the high emission levels would get us there in 2040. If we move over to the 3% column, you can see we get there somewhere between 2055 in this period of 2065 to 2080, and they showed that because there was just so much disparity within the individual models themselves. And then the last one is that at 4%, the 4.5 said we wouldn't really get to that level till after 2100, whereas the 7 and 8.5% warming greenhouse gas warming levels said we would get there in 2085 and 2075. So these upper and lower ranges, and that's the ones that are bold here, are what I took those numbers, and that's what gets transferred into the Titanic table. So when we say for 2 degrees Celsius, it'll be between 2040 and 2050, that's what that means. And those numbers are 20-year averages. Now, if you take a look at the column before that, the observed 9-year trend, that is really a 12-month cycle number. So you will see there obviously will be some discrepancy between those two because one's a 12-month number and the other one's a 20-month number. So you would expect the 9-year level to be much more responsive than the projection levels, okay? But anyway, that's how this table was created. I hope that adds to your understanding. Now let me just sort of wrap this up with sort of the reality we're facing here, okay? We have a number of political leaders and special interest groups and podcasters and other kinds of things, think tanks and stuff, that are claiming climate change is a hoax, a con job, a scam, right? We've all heard that. And then you have the client's scientific community saying, here's what's happening. So I think as an individual, we sort of have to decide, well, who do I believe? I've never heard, when the skeptics talk about this, they say, well, it's a group meeting over here somewhere, or some guys in a remote university someplace and are doing this. The green people are generating these forecasts, etc., and things like that. They never say, at least I've never heard any one of them ever say, yeah, these projections we are objecting to were produced by all the nations of the world bringing their scientific efforts, going through a disciplined 7-year process, running models, running 50 models in 6 continents, 50 modeling centers, running 100 models in 6 continents over a 7-year period, and everything being peer-reviewed, etc., by the scientists of the world, and everybody agreeing, both the greenhouse generating countries, the fossil fuel producing countries, and the people who are being affected by that, all agreeing that this is what's going to happen. Never have I heard anybody from the special interest groups ever say anything like that. Have you? But here we are. Each one of us, I've made a choice, but each one of us has to make their own choice, and that's what I want to say. But I want to also say one other thing. The choice you make has a profound impact on you, your kids, your grandkids, and the rest of humanity. So, if you want to say this is a hoax and I don't want to do anything about it, that's fine. But I think you ought to at least step up and say, yes, and I take personal accountability to what I do to myself and to my kids and to my future generations and to the world. I've looked at the evidence and I decided that's the way I want to go. All I ask is, if you're going to do that, recognize that you have an individual accountability as a human being for what happens in the future. It's not somebody else, it's you. It's each one of us. So let me wrap this up now. So we talked in this scenario how we calculate these projections. In video 7, I'll talk to you about why they really just sort of underestimate reality. It has nothing to do with the integrity or the intelligence of the people or anything. It just has to do with the pace. These are such complex efforts. They can't keep up with what's happening so fast. The second conclusion is that the only way we're going to solve this problem is we need to get to net zero greenhouse gases, and we need to do that now. And my other question is, what are you going to do about it? If you want to do something about it, one of the things you can do is vote in every single election at every level of government for somebody who believes that climate change is real and is committed to doing something about it, and also has a personality to work together with other people around the world to solve the problem. Yeah, if you're interested in seeing more, subscribe to this channel. We'll be doing numerous videos from now on out. I'm going to do, I've probably got 10 to 15, maybe more than that, maybe 20 videos, all the raw material for most of those videos done, but most of those focus on the science. So I'm going to do maybe one or two of those every month, but I'm now going to try to also focus on making sure I'm doing a video that talks about the pathways, how we get to net zero greenhouse gases, and what are some of the impacts that happen as a result of these rising temperatures. So I'll be doing new videos in those areas. Those new videos take a while, so that may take me, I may be able to do that at a pace of one a month or something while I produce a number of scientific related videos, so they have most of that done already. So with that, I just want to say thank you for your time and have a great day.